Hello guys, this is Tafadzwa from StackDev and welcome to our YouTube course. So in this tutorial, we are going to continue with our two-pointer technique where we use two pointers to solve different algorithms patterns that mainly involves strings and arrays. So in this tutorial, this is a continuation of the first two videos that we did initially. So if you haven't checked them out, you need to check them out first, where we are sort of like building towards this video. So in today's problem, we are going to solve a problem that is called merge sorted array. This problem is classified as an easy problem, but it's not super easy if you don't have, the concept of the two pointers. So maybe before I jump into this problem, let's just do a quick recap in terms of what we covered before in the two previous videos. And then I'll explain now a new technique that we are going to use to solve this problem. So if you can actually go ahead and jump to our whiteboard. So if you still remember with our two-pointer technique, we had an array which can be sorted or not sorted. So in this case, I'm just demonstrating, let's say, with a sorted array. So we had an array of numbers with these elements. So the two-pointer technique, what it says is you need to initialize two pointers, one which is pointing to the left side of your array input, and the next pointer will be pointing to the last element of your array. So the idea of this algorithm is we had a pseudocode which looks like this. So for example, you had a while loop, okay, which is going to iterate through this array once, okay, because you want to make sure that all of the problems that you're solving, you're only running this in linear time. So which means the runtime is supposed to be off n. So the idea is you had a while loop here, which was doing something like maybe while left pointer is less than the right pointer. Okay. You were doing some inside this while loop, we are doing some operations here. So here I'll just say op. So you're doing some operations here. And these operations, you either had to move the L pointer to the left, to the right actually, or move the right pointer to the left, okay, this side. So left pointer was moving this side, right pointer was moving this side. And as long as they don't cross, you continue these operations, or sometimes you have to move them both, okay, left pointer and right pointer at the same time, okay. So these were the three kind of conditions that had to be satisfied for the two pointers to move, either left or right, or both of them moving at the same time, okay. And then you close your loop here, and then you come up with whatever problem or solution that we're trying to solve here. So this was the sort of like the pseudocode of the two pointer that we have covered up to now. Now, what's going to be a bit different now with the current problem that we now want to solve right now is, so currently, so here, that's just also like a reminder here. Here we also need to make sure like whatever operations that we're doing here, we're doing it in constant time, okay. So these operations have to be in constant time, because if this is linear, what it means is you also have a while loop here, which is also linear. So it was going to be a quadratic, like off and squared. So you have to make sure that the runtime of whatever operations you're doing in the while loop, the ones that were responsible for moving the left and the right pointer, they have to be linear operations, so that the whole function will become linear, okay. So this was the idea. So if you haven't checked the videos, just quickly check the previous two videos where we explained this with some problems. So now with the current problem now that we now want to solve, I'm going to wrap this. So here you can see previously we're working with one array. So now let's say maybe you are given two arrays, okay? So let's say you have two arrays. This can be an array of integers or characters or strings or whatever. So in this case, I'm just going to use, I don't know, like numbers here. So let's say you had two arrays, okay, that you want to solve, I don't know, some operations or some algorithm. Maybe you are asked to merge these two arrays, or maybe to sort them, or whatever problem that you are asked to do. Okay, so with these two arrays, you can actually go ahead and use our two pointer technique. But the difference now is your two pointers are not going to reference to the same array. Okay, you're going to have a two pointer. Let's say P1, pointer P1 will be pointing to the first array, which is A. Then another pointer will be now pointing to the next element, which is array B. Okay, so this is still a two pointer technique. So what the sort of like a pseudocode will look like is you want to perform operations across between these two arrays at the same time, and you just need to make sure that whatever operations you're doing, again, these operations are running in linear time of n. Okay, so once they're running off n, that would be like the best case scenario here, where your runtime complexity is of n. Okay, so what the pseudocode will look like is it will look exactly like what we had previously, but the only difference is you now have two pointers pointing to two different arrays. So you still have some operations here where we are going to have your while loop here. Okay, so this while loop, it will be, so for example here, while p1, okay, this is the first pointer of the first array, is less than the array a dot length, for example. Okay, so you want to do while the p1, because you want to move these pointers. Okay, the idea is you want to move these pointers across these indexes, and you only want to do it once, and then that's it. That's how we make it linear. So here you can say while p1 is less than the length, because you want to move it across. Okay, and then you can say and p2, okay, p2 is less than b dot length. Okay, so inside this while loop, you want to perform again operations that look like the first scenario, like what I showed you earlier on. So you want to do some operations here. Okay, so I'll just say operations here, and these operations, it's either you want to do some logic which is going to move pointer 1, okay, to the left, okay, sorry, to the right, or pointer 2, you want to perform some logic here or some condition that you are checking here, which is also going to move pointer 2 to the right, or the third condition, exactly like what we had before, or pointer 1 and pointer 2 both moving to the same direction, +1 here. So this is what your while loop will look like. So it looks exactly like that one, but the only difference is your two pointers are no longer referencing the same index or the same array. They're referencing to two arrays. So the idea is whatever operations you're doing here, you are making decisions where you're moving either pointer 1 or pointer 2 based on whatever problem you're trying to solve. Okay, and in addition to that, okay, because here you might ask like, so for example, what if, let's say, pointer 1 is exhausts. So for example, in this case, you can see pointer 1 only had 4 elements, but pointer 2 here, it's referencing to 3 elements. So there is a possibility that maybe pointer 1 might finish or pointer 2 might finish before the other array is finished. So the pseudocode will look like this. So on top of the first while loop, which is going to determine whether you're going to move pointer 1 or pointer 2 or both, you also need to have another while loop here. Okay, so the second while loop is the one that is now responsible for making sure that you have exhausted all the indexes of elements. So for example, if the arrays are not equal, so for example, you might say maybe while p1 pointer 1 again is less than a dot length. So this condition looks like the one above, but these are now being done independently. So you can say while p1 is less than array a dot length, you want to do, so inside this while loop, you want to do some operations, okay, some op operations, where you want to move p1 to the left. Okay, the reason why we are only performing this while loop on the first pointer is like what I said. So let's say here you have exhausted, in this case exactly, you exhausted pointers in B, but here we are still maybe on the third element. So here we are left with 6. So you need to make sure that you've exhausted everything in pointer A. So this is what this while loop is doing. Then again, this will also apply to the second array here, which is B. So again, you have another third while loop here. Okay, so the third while loop will be responsible for pointer 2 now. So it looks exactly like the second one. So while p2 is less than b dot length. Okay, inside this, you now need to make some operations that is going to be responsible for exhausting the array, for exhausting the second array, which is the B one. So you need to do some operations here, maybe like check, I don't know, whatever you'll be checking. Maybe if this number is less than this one, whatever, you need to make sure that you're moving pointer to plus plus or plus one. Okay, so this is the pseudocode. This is sort of like the algorithm that we're going to be using to use the two-pointer technique to solve an array which will have two arrays and 2 pointers pointing to different arrays. So for the most part, you see that for most of these problems that you face, that looks that we have two arrays where you need to do maybe like a merging or sorting them or whatever. For the most part, this is sort of like the algorithm that we'll be using, where you have 3 while loops. The first while loop being responsible for moving them both or even individual, depending on conditions here. And the 2 second while loops will be responsible for moving, for exhausting the array. So for example, if the other one is smaller than the next one, you need to exhaust either A or B. So these 2 while loop will sort that out. And you realize that the runtime of this thing will still be O of n because it's going to be O of, so for example, the first while loop, maybe it's m plus O of, you know, mn plus O, big O of O. So all these things are still n conditions. So this algorithm is still linear for these 3 while loops. So it will still run in linear time. So I think not to make this long, I think I will end this video here, and then maybe in the next one, we'll then now quickly solve that 2-pointer problem, which I showed you earlier on, the one for the merge sort, where we are going to apply this technique that we just learned here. And we're going to stick to what we've been doing before, where I will show you the brute force solution and maybe an improved solution to the brute force, which will be linear ideally, and then maybe a super improved one. So I'll end this video for now, and then I'll see you in the next one. Cheers.